In this podcast episode, Dr. Donald Hoffman, a professor of cognitive sciences, discusses his research on the nature of reality and consciousness. He challenges the commonly held belief that our perception of the world is a direct representation of objective reality. Instead, he proposes that our brains construct reality as a user interface, similar to a desktop screen on a computer, to help us navigate the world. Hoffman's research focuses on two main strands, evolution and consciousness. He uses evolutionary game theory to examine whether evolution shapes sensory systems to see truths about objective reality. Surprisingly, his findings show that the probability of any sensory system perceiving objective reality is precisely zero. Evolution shapes sensory systems to guide adaptive behavior, not to see the truth. He also explores the relationship between consciousness and physical objects. Hoffman argues that space, time, and objects in space and time do not exist when they are not perceived. He uses the metaphor of a virtual reality headset to explain this concept. Just as icons on a computer desktop are not the actual objects they represent, our perception of objects in space and time is not the truth. They are simply representations created by our brains to help us interact with reality. Hoffman further discusses the implications of the Nobel Prize awarded for proving that local realism is false. Local realism is the idea that physical objects have definite properties even when they are not observed. However, quantum theory has shown that this is not the case. Hoffman argues that this finding aligns with his theory that space and time are not fundamental, but rather a trivial data structure created by consciousness. He challenges the distinction between consciousness and what is alive, suggesting that it is an artifact of our limited perception. He argues that everything we perceive is an interaction with consciousness, and the distinction between living and non-living is not principled but a result of our headset's limitations. Hoffman also addresses the question of defining consciousness. He explains that our perception of others' consciousness is limited by our headset, and we can never fully know someone else's conscious experience. He emphasizes that the body we perceive is not the person's consciousness itself but a portal to their consciousness. Furthermore, Hoffman discusses the role of science in understanding reality. He argues that science has moved beyond space and time as fundamental and is now exploring new structures beyond these limitations. He proposes that consciousness is fundamental, and space and time are just a trivial data structure. He suggests that science and spiritual traditions are converging on the idea that consciousness is fundamental, but science has the advantage of mathematical precision and experimental tools. Hoffman continues by highlighting the importance of creative leaps in science. He explains that theories have limits, and scientists must take creative leaps to explore what lies beyond those limits. While most leaps may be wrong or uninteresting, occasionally, they lead to significant breakthroughs. Hoffman explains that his theory is based on the idea that evolution is driven by competition. He gives the example of the jewel beetle in the outback of Australia, which is attracted to beer bottles because they resemble the female beetle. This shows that evolution only gives organisms the information they need to survive and reproduce, and not a deep understanding of reality. He also discusses the concept of supernormal stimuli, which are exaggerated versions of natural stimuli that can override an organism's normal preferences. For example, humans are attracted to makeup and clothing because they tap into our unconscious desire for supernormal stimuli. Hoffman then introduces his theory of conscious agents, which posits that consciousness is made up of a network of interacting conscious agents. These conscious agents form a new conscious agent when they interact, and ultimately there is just one conscious agent. He explains that this theory is supported by recent findings in physics, such as decorated permutations, which are mathematical structures found outside of spacetime. He suggests that consciousness takes on different perspectives through these conscious agents, and that space and time are just one of the perspectives that consciousness uses to understand itself. He compares this to wearing a virtual reality headset, where each person is a different avatar in the virtual world, but ultimately they are all part of the same consciousness. Hoffman also discusses the implications of his theory for morality and ethics. He argues that when we realize that we are all part of the same consciousness, it becomes clear that we should treat others with compassion and love. He suggests that competition and conflict arise from a lack of understanding that the other is actually a part of ourselves. In terms of what happens after death, Hoffman speculates that consciousness continues to exist and that nothing is lost. He compares the experience of death to taking off a virtual reality headset, where the avatar disappears but the consciousness remains. He suggests that meditation and spiritual practices can help us prepare for death by letting go of our identification with the avatar and realizing our true nature as consciousness. Hoffman continues by discussing his own spiritual practices, including meditation. He explains that meditation has helped him let go of fears, anxieties, and selfishness, and has allowed him to be more present and open to new experiences. He emphasizes the importance of balancing thought and presence, and of enjoying the journey of life while also being precise and careful in our actions. Hoffman continues by explaining his theory, which suggests that space and time are not fundamental aspects of reality, but rather a virtual reality headset that our consciousness uses to interact with the world. He argues that our perceptions are not a direct reflection of the external world, but rather a user interface created by our consciousness. According to Hoffman, our consciousness is not confined to our physical bodies, but is a fundamental aspect of the universe. He proposes that conscious agents, which are the building blocks of reality, exist outside of space and time. These conscious agents interact with each other and create the illusion of a physical world. Hoffman's theory challenges the traditional view of reality as an objective, external entity. He suggests that our perceptions are shaped by our evolutionary needs and are not necessarily an accurate representation of the true nature of reality. He argues that our senses have evolved to prioritize survival and reproduction, rather than providing an accurate depiction of the world. The conversation then delves into the implications of Hoffman's theory for our understanding of consciousness and free will. Hoffman suggests that consciousness is not confined to humans or even living beings, but is a fundamental aspect of the universe. He argues that all conscious agents, whether human or non-human, are interconnected and part of a larger network of consciousness. Regarding free will, Hoffman challenges the notion that our choices are determined solely by our brain activity. He argues that our decisions are not solely the result of neural processes, but are influenced by a deeper level of consciousness. He suggests that while our physical bodies may not have free will, the larger consciousness of which we are a part does. The conversation also touches on the role of love in metaphysics and the importance of relationships in our understanding of consciousness. Hoffman suggests that love is the recognition of the other as oneself and that our interactions with others provide valuable insights into our own consciousness. The discussion then turns to the potential impact of technology, particularly artificial intelligence, on our understanding of consciousness. Hoffman acknowledges the concerns about AI but suggests that it can also be a tool for expanding our understanding of consciousness. He proposes that AI could potentially open new portals into consciousness and help us explore the true nature of reality. Hoffman concludes by discussing his future research plans and the potential for his theory to revolutionize our understanding of reality. He expresses his desire to show that his theory can accurately predict the inner structure of protons and eventually extend to atoms and molecules. He believes that once his colleagues in cognitive neuroscience embrace his framework, they will make significant progress in understanding consciousness. Thanks for watching. If you enjoyed the video, make sure to like and subscribe.